Oh, oh, Mike, come down here. It's better. Excellent. Good, good, good. Okay, so, good evening. We have enough of this sorted out now. So, tonight. I have no idea how long this is going to take. Could be really short, could be really long. Yeah, we'll see. Shrug. Why are we here this evening? Well, this evening, we're going to talk a little bit about home networking. So, when it comes down to having internet in your house, you may have moved out, right? First time out, do what you gotta do. You got utilities, water, electric, rent. Maybe you purchased your first house. Maybe you have all that and a mortgage. Oh goodness. And now you're stuck with something that you need to do and something you have to take care of, setting up your home internet. Well, could be a little painful. Doesn't have to be. That depends on who your internet service provider is, to be completely honest. But when it comes down to it, and you've wandered in through the store, and you said to the person behind the counter, "I would like internet," and they say, "Okay, what do you want?" I'm hoping I could give you a little bit of insight as to how to answer that question. So, I'm going to work a little backwards with this. We're going to do it based on all the pieces you would need being individual, and we'll talk about some combo equipment. So, let's start with the worst case scenario. You situate yourself. You got in the car. You went to the store. You said, "Okay, I would like some internet. May I have some?" You sign the paperwork. You sign up for a plan. And then they say, "Okay, here's your modem." They say, "Okay, well, what am I supposed to do with this?" "Well, it's 5 o'clock. That employee wants to go home. I don't know. Maybe they gotta go to their platypus's piano recital." You've just been shoved out the door, given a box, and now you don't know what to do with it. Well, maybe we should take a look at the box. Figure out what we got going on. Right, so in this case, in this example, which is super goofy. Wow. We are going to go on the assumption that you were given a modem. Nothing more. Hi, Golden Wolf. Good evening. Thank you for stopping by. And what's said modem? You got a box. And I'm going to find the button I'm looking for. Wow. Right? Internet modem. That's it. I do have some examples. I am going to be showing you real equipment, but we're starting here. So, here's the theory. On the back of the box, there's going to be some stuff. Wow. There's going to be 2 ports on the back. There's going to be a round one. And there's going to be a somewhat square-shaped one. With some little notches in it. And there's going to be some blinky lights. So, there's going to be 2 ports on the back. One's going to be coax. And the other one's going to be Ethernet. have Ethernet/internet, because more than likely on the back of the box it's going to say internet or Ethernet. Or it might have another terminology, WAN. Wide Area Network, also known as the internet, because it's thick. There's lots of space for stuff on the internet. So, there's a lot of different labeling you can see on the back of this stuff. This is by far some of the most common that you'll see that's printed on the back. But, with just the one box, this doesn't get you everything you need. It gets you started, but doesn't give you everything you need. An internet modem that solely just gives one port, does not give off the Wi-Fi's, so your cell phone can't just hook up to that. It gives you one address for your whole network. Now, what am I talking about? Well, I'm talking about numbers that make the internet work. So, let me grab an example, because the drawing only goes so far, right? So we're going to switch over to the bench. And now that we're over here, we are going to take a look at one of these modems. Now, when you're given just a modem, it doesn't matter what brand any of this stuff is. What matters is that your provider that gives you your internet has put it on your account and turned it on. Because if it's not turned on, it's not going to work. So, this is a Netgear modem. And it does exactly as advertised. It gives internet. Well, it does that. And this one, actually, it says cable/internet on the back for where the coax goes, right? And that is the TV style of cable. Now, I have some actual examples here, and we're going to make some cables this evening. Like, this is a TV cable or coax that doesn't have any ends on it. But when we're done with it, I'm going to be able to screw it into the back of the connector on our box. And then, when it comes to where we are going to plug in our router, which is another piece of equipment we're going to talk about a little bit this evening, that's going to get plugged into this yellow port that says Ethernet. Now, like I said, different manufacturers call this different stuff. Like I said, it could be WAN, it could be, some of them actually say internet on the back, which I think if I look around here, yes. So this is a device that does multiple functions, and it actually says on the blue port internet. So this is a type of router. This one does wireless and wired networking. Like I said, we'll get there. But if I were to have these two pieces of equipment in my house, this port here that comes out goes into the internet port on here. Now, why does it matter? They're all the same shape, but there's labeling on some of them. Well, there's a reason for that. Because there's a reason for that, we're going to talk about it. When your home network is a thing, right? Right now, as far as we're going to be able to go is nowhere, because I have nothing plugged into this device, right? But there's a piece of equipment called a router. It's another box. It's going to get hooked into the WAN port that is on our internet modem. Now, why are they denoted? Why does it matter? There was a bunch of yellow ones on that wireless router. And why wireless router? That means that gives off the Wi-Fi, which is the stuff that your cell phone and your laptop connects to, right? That particular box does two things. It gives you your home network, and it also gives you the wireless function that everybody's super accustomed to and doesn't really give much thought to, right? When you go over to someone's house, you ask them, what's your Wi-Fi password, right? You don't say, what's your wireless router password? You just say, what's the Wi-Fi password? Well, Wi-Fi is one mechanism that you use to get online, right? It allows you, without plugging in an Ethernet cable, which is one of those cables that's going to connect these two pieces of equipment, gesturing, and I'm not on the right screen, haha, that's better. These two pieces of equipment together. It's called an Ethernet cable, right? That's the one that, it looks like a big phone jack. If you've ever used a landline telephone. Yes, I'm old. It's okay. We all get there at some point. It looks like a bigger version of one of those. And they are not interchangeable. Because A, they're different sizes, and B, there's different wires. So, you ask them, what's your Wi-Fi password, right? And then you give it to them. Well, when their device connects to your network, it goes on the Wi-Fi, and then from there, it hits your router, and then your router does some stuff, right? Well, what does your router do, right? Because it's a box you know you needed, or you didn't know you needed, right? That gets you to the modem, and then all of a sudden, magic happens over that TV cable that's screwed into the back of it, and then out it goes. It's out of your house, right? Goes out on the telephone pole, and magic, you have cat videos in front of you now, right? Well, what the router does, in its simplest form, is it allows to route information between you and everything that's outside of your house, right? So another thing that routers are called are generally firewalls. That's another name you might hear for this piece of equipment. Right. So, what does that mean? Well, a firewall is something that keeps you on a very surface level safe while using the internet, right? There is, at its most basic level, all the firewall does in a router is it only allows for traffic to come into your network that you asked for, right? You say you want to go to Google, right? I want to search for cat videos. Well, in my browser, I type Google, google.com, and I click enter. Well, as I'm clacking away, and I click enter, that request for Google is put inside of a little box that we call a packet, and then it's sent over to the router. Now, the router has to make a decision on what to do with your request for Google. What do I do with it? I don't know where Google is. Well, the router has to figure it out. The router is based on some incredibly simple logic as to why there's ports on the back with labels. Like I said, there was the one on the back that was labeled Internet. There's a reason for that. The Internet port is the way out of your network. So, when I asked for Google, it hits the router, and the router says, the request from your computer asks the router, how do I get to Google from here? Well, the router looks at its table that it uses to keep track of stuff that you've asked for, and it either give you a direct answer, or if it doesn't know, it sends it out the Internet port. The default path for when your router doesn't know where something is out that wire. And then that wire gets you to your internet modem, and then from there, more or less, the magic of the internet happens. It hits that, and then there's just a pretty much an endless string of routers beyond your modem. And what happens is that your packet in request for Google goes out on your internal router in your house, to your internet modem, to other routers that are on the other side. And then from there, those routers then have paths to find their way to Google, right? In a more simplified version of this example, you want milk, a glass of milk. Well, where do you normally go in your house for milk? Well, you would think the fridge, but you're out of milk. Okay, well, how are you going to get more milk? You got to leave your house. So, how do you get out of your house? Well, most people use the door, right? Well, you need to know where the door is to get out of your house. And that's kind of what's happening here. Okay, so amongst the routers, and in the example when I showed you briefly, there was a small block of ports that are on the back. And they are labeled simply Ethernet in the numbers 1, 2, 3, and 4. Right? That's what they're there for, right? Well, what are they for? On your home network, people are familiar with getting their phone online by just putting in Wi-Fi password, right? And that gets you the distance. But say you have something like a desktop computer that doesn't have built-in Wi-Fi. Well, if it's got an Ethernet port on the back of your computer, which looks just like the jacks on the back of that piece of equipment, that's how you plug it in. You plug it in with an Ethernet cable. And then that allows that computer to use your router without the need of wireless equipment. So if this is just a simple router that doesn't have a Wi-Fi network that you would connect to, then you plug in the wire and you now have internet. Because it's got a direct connection to the piece of equipment that's going to get you out. Now, the fact that there's 4 ports on the back of that router that you could plug any device into that has one of those jacks. A laptop has an Ethernet jack. Desktop computers have Ethernet jacks. There's other smart devices, like even though smart televisions, people generally put on their Wi-Fi, there's almost always an Ethernet jack that's on the back of those. You could plug that into there, right? Well, that set of 4 jacks that we have on the back, 1, 2, 3, and 4, right? 1, 2, 3, and 4. That block is also known as switch ports. Now, there are dedicated devices that you can buy that will do switching, and they're just called network switches, right? Those 4. Well, say that we don't have wireless, and our home network just simply has stuff that we plug in. So we've got a desktop computer on the first port. We've got 2 smart TVs. One's plugged into 2, one's plugged into 3. And now you've got a laptop and maybe another device you want to plug in. Well, now you've only got 1 port left. What do? Well, if you want to plug in more stuff into your home network, well, then you need a thing called a switch. And what a switch does is we plug the switch into any of the available ports. Doesn't matter on either one of them. If it's a small 5-port switch, there's no specialness happening there. There are more complicated switches, but we're not going to cover those. That's outside the scope of this conversation. And on our switch will be more network jacks. So, we plugged in port 4 into port 1 of our switch. And now we've got 1, 2, 3, 4 more ports available. We could plug more stuff into our network, right? And that's just another Ethernet cable that you just pick up and buy off the shelf. Granted, They come in a variety of lengths, and that's perfectly okay. Maybe you need a really long one. Maybe you need a really short one. Well, if it's a pre-made cable, like ones you can buy off of online retailers or, your local electronic shop, anything that just says it's an Ethernet cable that you can buy in today's market will do the job. There are a fair amount of incredibly boring things I could tell you, like the fact that there's cable standards, and that the fact that there's different speeds that the different cables are rated on, and there's different types of wire in said cables. But honestly, it's outside of the scope of what we're going to talk about. All you got to know is that if you ran out of ports on the back of your router, you plug one cable in an available port, and you plug it into your switch. Now, switches come in a variety of sizes. You can get one that's 5 ports. You can get some that are 24 port. You can get some that are all the way up to 48 ports. Those are some big switches. And with that, you can plug in a lot of stuff. Generally for a home network, you're not going to see something that big. Unless you like to play with networking equipment, which then you are going to have something that big. So, with our little home network, we have our switch, right? But, as I mentioned, in its simplest setup, this is just a router, right? And its most basic firewall function is that I'm not going to let anything in from the internet that wasn't requested from the inside. So, I want to go to Google. My computer asks for Google, and the router says, okay, sends it out. And then when stuff comes back in, it says, I'm back for the computer that was looking for Google. Where is it? And it says, oh, okay, that was requested. Come in. If something comes knocking on your door and it says, I'm from another part of the internet and I want to come in, well, the router promptly is going to ignore it because it wasn't requested. That's most basic level. That's what a router does. It just simply allows stuff to go out and allows stuff to come back in. Now, with this little drawing we have here, as I'd mentioned, this setup doesn't have any ability for wireless as it is right now, right? And if your internet service provider gave you simply just a modem that does nothing else and has just a coax and Ethernet, well, then you need either one device or two. You either need a router and an access point, or you need a combo device, which is both a router and wireless. I have a few examples I'm going to show you this evening that are one or the other. I've got one that's just a router, there's no wireless built in, and then I've already shown you the one that is both. So, with that, I'm going to switch back to the bench. I want to show you something. Okay, so this is our combo device, right? So this is the one that we know it's got wireless antennas on it. This one can totally give you Wi-Fi. And on the bottom, there's a sticker that indicates what the name of the network is and what its password is, right? And if you wanted to change nothing about it, you wanted to just plug it in and work, and then maybe you want to screw with it later, you can do that. But on the bottom, it tells you everything you need to know to get connected to it. And it's in its most basic form. We're going to hook up these two using this port. But before we get there, I want to show you what a router that does not have wireless built-in looks like. So, this is a EdgeX router that's made by Ubiquiti, and this gives you a wired network, but no wireless. So, like in my little doodle of a drawing, y'all understand why I'm not an artist. This is the setup so far. You've got your modem, screw it into the wall, your connection to the internet,
and then you need to connect to the WAN or the internet port on the router. Now, you're going to notice there's some bright yellow labels I have on this. One says WAN, and the other one says LAN ports 1 through 4. This box out of this device out of the box doesn't work. It's a doorstop. You have to actually go into it and set it up to work with your modem. Now, this is more of a prosumer, like you plan on messing with your home network, which is why it doesn't have anything like that set up on it, right? But I put some labels on it just so I would know that if I was working on it or I had to deal with it, what ports mattered, right? Internet's got to get plugged into Ethernet 0 or ETH 0, and then the other 4 here are for stuff on my home network, right? And if I had an access point that was just simply an access point, right? So picture a box with some antennae on it that only has an Ethernet jack. That's actually where I'd plug it in. I'd plug it into one of these available network ports, right? Now, not that I have anything to make with this. I do want to show you something that's kind of neat. In a more commercial environment, the routers get bigger. This is the larger model of the baby. The smaller one. Now the smaller one has all the same functions that's built into the bigger one. Why do we have the bigger one? Well, the bigger one is capable of passing more traffic in a shorter span of time. It's able to handle more packets. Ubiquiti has on their website all the statistics that make up why this one can move more than this one. I don't know the nitty-gritty of it, but in addition to it being able to handle a little bit more traffic and handle a more of a commercialized environment, like when you would have a network with, I don't know, 20 or 30, 40 computers, well, your router needs to be able to handle that amount of traffic, right? This little guy is perfectly fine for, I want to say it was a million packets per second. I believe that's what it was. And then this one's capable of doing more. Now, for a home network, you're not going to have that much stuff connected, right? If you wanted to play with networking stuff and kind of get into it, then yeah, you can get one of these little guys for like 30 or 40 bucks. It's the EdgeX router. It's a Linux-based operating system, so if those words don't mean anything to you, I recommend doing a little bit of research. It's a fantastic piece of equipment to hop into. No, I'm not sponsored. I'm just a nerd that likes their stuff. But on the commercial piece of equipment, this does have something that the little one doesn't have. And that would be a third Ethernet with this weird rubber cap covering it. Well, this particular router is capable of being hooked into a fiber optic network. Now, if I remove the little dust cover, the little boot, we will see pretty much a hole with a connector in the bottom. And what that little connector is for is to plug in your respective device that then connects to the network. What any of that means is that in the world of fiber optic does not use copper, right? There's no individual wires to hook your home stuff together, right? It's actually a thin strand or multiple thin strands of glass. Well, this is the little dude that you would plug into something like that, and it's called a GBIC. Now, what we do with this is we take it and we actually slide it into the available slot and let that rotate up. Now, I have the GBIC now installed inside of this router. So if I had a fiber optic cable, I would plug in the send and receive. There's only one for each when it comes to this style of fiber optic, right? It's something that's very strange to think about, right? Because you're moving traffic over beams of light. Super weird, right? But it's just a way in the commercial space that people move a lot of traffic in a short amount of time with less interruptions that could be seen on the network, right? I do realize that this little device itself could be its own whole conversation all by itself. But simply know that there are more than one ways to move traffic around the internet, right? Or inside of your own internal network. In the case of this particular box, you've got your Ethernet cables that you can buy at Walmart or, like I said, big box stores. Or in this case, we're going to take some of this scrap wire and make some cables that then plug in here. Or you can use something like this to use beams of light that just shoot down a thin strand of glass that's no thicker than a human hair. It's incredibly thin stuff. It's actually kind of fun to play with. I would show you one, but I don't have one on hand. I just had the GBIC that I pulled out of one of my switches. But with that being a piece of commercial equipment, and the funny thing is that when it comes to like the big stuff, like stuff that makes like big commercial buildings run, like the stuff's bigger than this. Size wise, the equipment can get kind of wild, which is why when it comes to where all the stuff is hosted in a big commercial building, usually there's a fair amount of air conditioning because it gets kind of hot. Okay, so with that and some of my rambling, we're going to make some cables. So this is a chunk of Ethernet cable that we're going to put some ends on, and then I'm going to show you how we test it to make sure that it will work. And then we'll just plug the pieces of equipment together just so you can see all that in action. And we need one of these. Okay, so we've got some basic tools, we've got some specialized tools, we've got some madness. Okay, so inside of this piece of Ethernet cable, there are 4 pairs of tube. And they're all colored. We've got orange, green, brown, and blue. Now, inside of the connector that ends up plugging into your equipment, the wires have to be in the right order in the connector head for the cable to work correctly and for you to be able to get online and watch your cat videos. So, most cases, in pretty much all of the US and I believe Europe, that part of the world uses the Ethernet B wiring setup. And that means that the wires are going to go in the order of orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Now I am saying multiple colors for some of these, because as I am getting these untwisted, they have colors that share. Because there is a normal solid orange wire, and then twisted within it here is one that's orange and white. So, once I get them apart here, you can then see amongst the fibers here. All this little fluff is just to allow you to help pull back the cable sheath, but honestly, one of these is so much better, because it just cuts it at the length you want and you slide the top off. Yes, once we get the fibers out of the way there, we've got our orange pair, our green, our brown, and our blue, right? So what I'm going to do is I'm going to get them in the appropriate order. We're going to trim them and then put the connector head on. So as I'd said, it's orange, white, orange. Green, white, blue. Blue, white, green. Brown, white, brown. Now, when it comes to actually buying stuff to make these cables, right? The average person is not going to be buying this stuff unless you have, a whole house that you want to add a bit of a, a larger network, or, say you have your computer is in your bedroom upstairs and wireless signal doesn't really get up there all that well. And if you hardwire it by plugging in an Ethernet cable, well, then it doesn't matter really how far away it is or if there's a whole lot of craziness going on. As long as the cable that you're making is shorter than 365 feet or 100 meters, you can make a cable. That is the maximum length of a cable between two devices, whether that's two switches or two routers or two computers. It can't be longer than that without something in the middle. Blue, white, green, brown, white, brown. Okay. Alright, I got these guys in order. I'm going to give them a trim. And then while attempting to keep them in order, I'm going to slide the connector head on now. Orange, red, orange, green, white, blue, blue, white, green, brown, white, brown. Okay, that's looking pretty good. Before I crimp it, I'm looking on the sides to make sure that the wires went all the way up into the top of the connector head. If you look at it from head on, it's going to be really hard to see with this camera. I do apologize. You will see 8 little dots, which would indicate that all 8 wires are running through the channels. And again, the same thing on the other side. Now, when you think about grilling, I know, side tangent. Tell me what this sounds like. The clickiness of one of these tools reminds me of the tongs that one uses when they grill outside. Does it not? And also, I gave them a little bit of a clack together before actually putting the head on. I didn't have to do that, but I feel like it's almost the human condition. It requires us to do it. Even though there is no rhyme or reason to do that. But I did it anyway. Now when I give that a little spin around the wire, what it is doing, there's actually razor blades recessed in this tool. And it's incredibly safe to use as long as you don't put your hands anywhere in there. It allows you to very safely remove cable sheath without cutting your hands. Because the last thing anybody wants when they're standing in a wiring closet that's probably 100 degrees, or better yet, you're in your basement, trying to run a wire from the basement up into your living space, or, heaven forbid, you're trying to run it from the basement through your attic, trying to add wireless to other parts of your house. The last thing you want to do is cut yourself while trying to put the ends on the cables. No one needs that in their life. Alright, so we got orange, white, orange, and green, white, blue. Blue, white, green. Brown, white, brown. I am doing that off camera because it's kind of hard to show you that I'm just doing the same thing again. The toughest thing is getting, because they're twisted pairs, is getting them so they sit flat. Orange, red, orange, green, white, blue, blue, white, green, brown, white, brown. Now, what I do mention, and it's funny enough, the symbol, this color pattern's on the side of my Protogen. I'll show you that in a minute when I go back to the workstation. There's a reason that that's on me, because I can't forget it. I need to use it every day. So, it follows me. Quite literally everywhere. Okay, it's trimmed. pop this guy on here. Green, white, blue, blue, white, green, brown, brown. All right, fabulous. Okay. Squeeze for good luck. Fantastic. So, if I had done this correctly, this is going to be a functioning cable. It's incredibly short, but we're not going very far. I've got a modem and I've got a router. I don't need to go incredible distances, which is why it's short. I could have made it longer, but I didn't need to. What's important though, other than the fact that the length has to be less than 100 meters, is that I got the wiring correct on both sides of the connectors. Now, obviously visual inspection is the place you should start, because if it looks like it's not all the way into the connector, well, it doesn't matter what the tester says, it's not going to work right, and it's going to tell you that it's wrong, but either that it didn't actually affix the end of the wires because they're not all the way into the connector. And the other thing too is that you see that this blue cable sheath is inside of the connector head. That's good because there's actually a little punching tool here that crimps down on top of it that gives some strain relief to the cable end. If the wires are all loose and this cable gets a good moving up and down, well, then you can break wires. By making it so that the cable sheath, the blue part of this, is inside of the connector head, gives us some strain relief. Just super helpful so you don't, damage your cables. Let me grab our tester. Okay. So this tester is super helpful for checking to make sure that I wired this right, but it also has different functions, like it can tell you the length of a cable. It can help you tone a cable. I will showcase that, but I'll come back to that. It's got different stuff it can do, which is helpful. In the case of our Ethernet, I'm going to plug both ends in here. I've got the remote end, which is the little piece I popped out, and then I've got the tester. So this is what it looks like before I turn it on. And then I'm going to flip the switch and then see what the screen says. That's pretty exciting. Very rarely can I say that I get a run on the first try. I do most of the time. Sometimes I split pairs, but I see the word pass on here, and then 1 to 1, 2 to 2, all the way to 8. All the way across, which means this is a straight through cable. That doesn't necessarily mean I wired it correctly. I mentioned there's a color order, right? If I had put these wires in the connector in a random order, and I ran the test, it's going to pass because it's going to be a straight through on both sides. But the reason that you do it in the particular order that I had mentioned is because inside of this cable sheath are those wires, and they're all twisted a certain amount all the way down the wire, right? Well, there's a reason for that, and it prevents crosstalk and other noise that can come on the line, right? Let me talk a little bit about that.
Okay. Crosstalk and noise. It's frustrating. It's irritating, but it happens, right? Inside of that Ethernet cable are those 4 pairs of 2. They're all twisted a certain amount, right? The orange and the blue tend to be the most twisted, and then the green and the brown are the least twisted. And then inside of the cable together, the 2 pairs of 2 are all twisted together, right? Pop the end off, put the end on. Pop the sheath off, put the cable end on, and away we went, right? But the reason that is because electrically speaking, that gives us the best resistance to bad stuff that can happen with those cables, right? What kind of bad stuff am I talking about? Well, in the space of networking, data is sent in what's called low voltage, right? It's pulses of electricity that go down those little wires. And those pulses are pretty much your request to get online, right? And while it's going ham and giving off those little pulses, things in your environment could mess with those pulses. And what the twisting does is it prevents external forces from messing with you. Or at least it tries its best to, right? One example would be a pool pump, right? On a pool pump that keeps the pool clean is a big motor. And the big motor gives off what's called electromagnetic interference, or EMI, right? Those are invisible waves that you can't see that causes disruption in a low voltage application like Ethernet cable. So it is good to know that if you're actually going to be running, say, an outdoor access point because you want to have Wi-Fi by your pool, or maybe outside in an area where you and your friends hang out, or you want to have, a meetup or whatever, and you want to have something outside, you don't want that cable to go by something that can do a lot of noise and cause you trouble, like a pool pump. You'd want to avoid the big motor or an air compressor. That's another motor-driven device. Motors are really bad at giving off that kind of stuff. That's just trouble. So, with that, let me find my train of thought here. Yes, so I don't want this to get too complicated. I think it kind of has, but I'm hopefully not losing all of you in a short span of time. We're going to make the coax cable next. And we're going to make another Ethernet cable. And I'll be open to some questions. We're going to talk about how this stuff actually hooks together. I don't know I've already talked about it, but we're going to plug some stuff in, right? So, let's transition back to the bench.
So, the coax cable, I actually can't test with this. I can use it to tone it, but I can't test it. And honestly, it's not that big of a deal, really, because coax has only got one wire in it and a cable sheath. So I actually kind of can't wire it wrong, but it does need ends because I can't just take this chunk of wire and stick it in the back here. I need to actually have something to hold it in there, right? So we have some nifty tools to do that as well, which I think I left on the phone. So, just like the specialized tool that we had here for taking the cable sheath off of the Ethernet cable, I also have a specialized little tool here for actually taking the insulation off of one of these. Now, the nice thing about a tool like this, that it's got some stuff stuck in it, come out now, there we go, is that this is going to measure and cut a couple different layers, which is why I'm using this one over the other one here. All right, so I'm going to push up the guard. I'm going to slide the cable in. I'm going to give it a spin a couple of times and pull back. So that has done a couple different things. I removed the black outer cable sheath. That much. It peeled back this insulation, right? And then it exposed the copper that was in the center. Now from here, all we have to do is put on one of the compression ends in the tool, and this will be done. Putting ends on coax is so much faster than Ethernet because you're only dealing with one wire. So let's do it. Now, an important thing to note, if you're ever making cables yourself, is that you don't want the outer silver hair-like insulation that protects the inner sheath to touch the copper, because that grounds out the insulation and it doesn't work correctly. Now, all you really got to do is give one of these compression ends a good push and twist so that it's on the cable, And then there's the white of the inside of the cable that you can see that just needs to meet to the back of the connector head. Once it's in the whole way, you grab the compression tool, you pop it in, and you give it a squeeze. And just like that, we have something that I can plug in now. I'm going to do the other end real quick. Okay, so I slid the end on. I'm going to do the same thing. Give it a squeeze. And just like that, we have a tiny coax cable. So now that I got ends on here, I can take my modem and I can now successfully connect it on the back. Now, at this point, the other end of our little friend here, we would screw into the available jack that's on the wall. The whole thing about internet that's provided via coax is that, well, both ends need to be connected. Your internet service provider, if you're in, say, like a rental, right? You're probably already going to find that there's some cable floating around your apartment. Not all of it may be hooked up. So, if you've been told by your internet service provider that the place is pre-wired or that it previously had service, if the first jack you find doesn't work, try any of the other ones that you have available in your apartment. It may simply be that those aren't wired. And what that means is that even though this could be a jack that's just on the wall, if I go to screw into it and the other end is loose, like this right now, if I plug this in and power it on, we're not going to get internet because this isn't connected to anything. Well, the same thing happens with the wire that's in the wall. If that's not connected, you're not going to get online. Simply try a different jack and then go from there. So, if we were to pretend that this was plugged into something, we would then plug our friend here into power and then use our Ethernet cable to plug into the jack that's marked Ethernet on the back. Plug this guy into power and let it start up. There are lights on the front. You've got power, and then you've got a down lightning bolt, an up lightning bolt, an earth symbol, and 3 little squares with a line in the middle. And what these are is downstream, upstream, internet, and network. And what they mean, the first 2 is just your basic connection to the other end of this coax cable. Nothing more. That just simply means that there's functioning equipment on the other end and it's trying to communicate. It may not necessarily work correctly, and if you have trouble at this layer, then you do need to talk to your ISP as to why. If you can't get online. Because if you don't get both of these 2 lights, the down and the up, then you've got a problem. Either that could be a problem in your house, it could be a problem from the wire that goes from your house and connects out to the telephone pole and either goes, well, it could be an underground cable or on a telephone pole. Not all neighborhoods have telephone poles, but you get the point. And then the internet light means that it is actually connecting to the internet, and then the network jack on the bottom here, the little 3 lines, is network. And that means that you've successfully connected something to the other end of this cable, and now it's talking between the modem, which is this guy, and then your router, which in the case of our little EdgeX friend here, WAN, wide area network, or the internet port, like it was labeled on the combo, which is this one, we plug into WAN, or in this case, internet, right? So, with what we have right here is what I crudely drew in MS Paint. We've got our modem that connects us out to the internet. we've got our router now that gives us our home network. And then everything that we plug into this device is what's going to be able to get online. Now, with this being just a router and not a wireless router, the only internet you're going to get is stuff that you physically plug into this. So, when you're looking for something to buy, right? If your internet provider simply gives you just a modem, which is what the Netgear guy here is because it's got coax on the bottom, you are absolutely going to need and be required to buy a router. Now, what would make the most sense, since most people need wireless, if you only plan on having a really small home network, or you don't want to do anything too terribly complicated, something that you can get off the shelf like this, that you just plug in said network jack into the internet port, will get you the distance. Because almost all of these anymore that you can buy off the shelf, you can just buy it, plug it in just like this, power it on, and it's going to give out internet, and it's going to work. And on the bottom, it'll have the name of the network and the password to allow you to connect to it. If you have no wired devices in your house, this is easily the simplest setup you can go for if you only can get just the modem and it's not both, right? So major ISPs can take these three devices, right? The modem, the wireless router, and a switch if you need it, right? As I mentioned in an example, there are ports on the back here, and these are network switch ports, right? And if I wanted a bigger network of more than just 4 things, I can plug this little switch, which has got, looks like it was an 8 port. This is a 6 port, uplink being the one that you would hook this into this here, right? You plug in one of these ports into one of these, and that gives you 5 more things you can plug in that could be wired in on your network without with no configuration. Simply just plugging this little box into one of these available ports on the back is all you need to do. You just need a cable that works. Whether you buy one off the shelf or you make it yourself, it works all the same. Okay, let me switch back to our other view.
I'm going to add to our example because I've talked a whole bunch about it. An access point or wireless. Like I said, an example of what we have, our router, an access point, and switch are all that one box, right? But say that your ISP doesn't give you just a modem. Most don't give just this anymore unless you specifically ask for it, right? Not everybody does though. Some ISPs or smaller internet service providers only hand out the modem, and you're responsible for all this other stuff that needs to be plugged in, right? But if you've got one of the larger internet service providers, you may end up with a box that simply does it all, right? You get a box that has the coax on the back, and it's just a box, and think of what they actually run. Usually they'll just say, they may just say as a modem. This is where things get a little confusing, because it's surface level by having that coax jack that you screw into the wall. That is an internet modem. But the fact that it can have extra functions, like having the wireless or the Wi-Fi built in, so then all you have to do is look on the bottom of your Wi-Fi cable modem router, right? The name of all these individual things in just one box. If your internet service provider provides one of those, well, then you don't need to buy all this extra stuff. Them just giving you, I thank you for the poll. It is very much appreciated.
Thank you. Hello. How are you doing this evening? I'm here talking about the madness that is known as the internet. I know some ISPs make this easy, some do not, which is why we're here tonight. Some ISPs give an all-in-one. An all-in-one is nice, because there's less you need to know just out of the gate. There are plenty and plenty of self-help articles. You're welcome. That you can find on the internet that can help you understand this stuff. Like I said, you're getting a crude drawing from me. I'm not much of an artist. I play with networking equipment. This is what you're gonna get, folks. It's not pretty. It's MS Paint, but it's free. I am actually not studying anything. I do networking and troubleshooting for a living. Tracking, where'd you go, dear? Thank you. So this is some of the madness that I do throughout my day. One of the most difficult things when you have an internet connection that doesn't work, yeah, thank you, is trying to figure out where the problem may be. And when you have multiple pieces of equipment, well, that's multiple points of failure. Because if you think about it, if we take our little internet modem up here, right? And that's all good and fine and dandy, but then the power or the router dies. I don't want the eraser. What are you doing? Come on, man. I've lost my ability to draw, apparently. Come on. Oh. Well, case in point, I've irritated this in some fashion. There we go. Well, case in point, I've irritated the drawing tablet. Say that the power kicks out on your router, right? And this piece of equipment dies. Well, now you've got internet coming into your house at the modem level, but now none of your stuff is going to work here. There's not going to be any functioning wireless. Even though it's going to be on and you're going to be able to connect to it, right? You're going to see that your home network's on, but you're not going to be able to get out to the internet through it because the piece in the middle isn't working. Now, the piece in the middle could not be working because it's unplugged. Maybe you've got a power strip, right? One of the biggest things with power strips that drives people nuts is that there's a little switch on them, because if there's too much power pulled through them, what happens? They trip. Well, you have to reset them. Maybe someone accidentally clicked the button and everything plugged into it went dark. Well, if only one piece of your home network is plugged into that and not all of it, you might have to fight tooth and nail to find what is off. So when it comes to troubleshooting something that's got multiple levels like this, right? Start at the absolute bottom, right? Make sure everything has power. Is it all on? Because if there's no power and it's not on, you're not getting online. It's not going to go that way. Once you've checked that you make sure that you have power, well, then you want to make sure that everything's connected properly. In the case of our example that has multiple levels of stuff here, right? The internet modem has to be plugged into the WAN port of the router, and then everything that's plugged into the switch. That's the nice thing about the switch, is that if you have like multiple wired computers or wired devices, like say you have a camera system that has a wired port on it, right? You just plug it into any of the available switch ports. It doesn't matter because they're all the same. If you end up wanting to do something more complicated with the switch and get a managed switch, you absolutely can. But for our simple example, any of the small switches you buy off of the shelf that are 4 or 5 port, you just plug them in, they work. It's fantastic. There's not some madness involved into making the things happen here.
But the less points of failure, the better. When an ISP gives you it all, all in one box, where the modem and the Wi-Fi is one thing, well, you have one thing you have to look at to be able to determine what the problem is. If there's no lights on this box, well, you now know who you need to call. Exactly. Power cables are your friend. When it comes to the cables that hook all this stuff together, like the Ethernet, well,
one of the most important things about these particular cables is they don't get crushed and they don't get exerted, right? Because if you bend these too far, you could break the wires that are inside of here. Because when it comes down to it, all that's inside of one of these cables, as I had shown, is just a bunch of individual cables. And if I hack this in the middle, pull the sheathing back, if these little guys get crushed, right? The individual pairs that live in here. And that could be something incredibly simple, right? Okay, yeah, if your router only has 4 ports, then it's actually probably very similar to one of these all-in-one units, where the Ethernet plugs into the bottom, and then there's the 4 ports on the back that allows you to plug in any of your stuff, like your computer, your laptop, that you don't want to put on the Wi-Fi. If the cable gets damaged amongst these 4 cables, the 4 pairs of 2 that live in the center of this cable, well, then you're going to run into some really strange problems. Because if only one pair dies, and we're going to say the brown pair, for example, nighty-night, that could be broken inside of the cable, and you're not going to be able to see it because it's hiding in the sheath. Well, what could cause that to happen? Well, if the cable was too long, and you're in your office chair, and you roll over it with a really heavy chair, well, you can not only crush the wires, you can end up breaking them inside, and you're not going to be able to see them, right? Well, because of the fact that you can't see that is what the testers are for, right? With the testers, as to why not only did I test it to make sure that it worked, to make sure that I got all the ends in appropriately here, it mentions if everything's wired correctly. All right, this cable is currently passing. All 8 wires are correct from end to end. And they're also, I know they're wired in the right order because I put them in the connector in the right order. But let's say that this cable now gets damaged. So now, instead of it being a nice functional cable, we're going to lose some of it. I don't know how much of it. We'll see how much of it I can cut without completely mashing its potatoes here. Right? I just collectively jacked up this cable, something fierce. I stripped some of them. Some of them have the insulation exposed, and others I know I cut all the way through, at least one of them. I put the tester back on here. Lo and behold, Houston, we have a problem. I managed to mess up the brown pair, pair 7 and 8. And if I jiggle these around a little bit, because I cut through them, I might be able to make a couple others fail here. If I give it a good twist. Would you look at that? I have 6 now connected to 7. 6 isn't connected and 8's missing. So it's now very upset with me that I did that. But electrically speaking, this cable's very much garbage now. Something as obvious as this as me cutting back this cable and pointing out the problem is incredibly obvious, right? And with that being that it's completely obvious, it's easy to find. Well, without seeing that up front, right? Where's an Ethernet cable going to end up, right, for your internet equipment? It's probably going to be on the back of your desk, lost and forgotten, probably covered in dust, maybe hanging off the back of the desk. Who knows? It's usually not in the forefront of people's minds when they have networking troubles. And a perfectly good cable that you started with can get damaged over time. Maybe if it doesn't get run over by a chair, maybe you have cats. Cats love to chew on wires. And I can tell you I've replaced my fair share of them because of cats liking to nom through the insulation. Now, that kind of damage is at least somewhat noticeable because of the simple fact of a bunch of little holes on that nice blue cable that I showed you. Checking the physical air is, oh god, yes, rats. Oh, there was one building I was working in, that reminds me, oh god, where I was terminating some cable, and the cable was above the drop tile. Well, the building did have rats. I didn't know that at the time until I put the cable tester on the cables that were pre-existing. I did not run these, they were already in the building. I ran the cable test, and all the pairs failed because it was showing that they were all shorted together. Well, I pulled the cable out of the ceiling and tied a new one to it to replace it. You know, that's an easy way to replace a cable, is just tape a new one to the end, pull it through, and then you're good to go. And what did I find? But a ton of exposed copper. Just like that I had shown you in the one I just mashed its potatoes. And with a tester like that, it's actually really easy to find the problem. Now, that one particularly, I think that's Southwest Wire. That's like an $80 or $90 tester. But you can get some incredibly cheap ones for like $10 that you could buy off of really anywhere online that will just go through the pairs one at a time, 1 through 8. And as long as they appear 1 through 8 on both sides of the tester, then you know you've got a passing cable. Usually they come with some fairly broken language, or usually it's just pictures that might indicate how to use it. But easily the most basic tester you can get your hands on. As a matter of fact, let me take a moment here and see if I actually have one of these. Let me check my box. I do have one. Let me grab another cable. One that I did not mash the potatoes on. Okay, this is an incredibly cheap tester, right? I'm pretty sure I spent $5 on this tester. It does Ethernet, and it does phone. Phone is RJ11 is the name of the connector, and Ethernet is RJ45, which is the wider and the bigger connector, which is the one that we use in networking equipment. With this tester, on a known good cable that I could show you, like this pre-terminated black one I just grabbed off of my bench here, I'm going to go ahead and plug these in, and I'm going to turn it on. And it's going to cycle through the lights, 1 through 8. Now, something else that this tester has that's not going to light up is this G on the bottom here. What the G stands for is ground. Some Ethernet cable does come with a grounded shield inside of the cable. This particular one that I showed off here does not have a grounded shield. And if you have cable that's grounded shielded, you actually need special connector heads that accepts the shield, and then that light will come on. But if there's no grounded shield and you don't have those special connector heads, it doesn't come on. I mean, I do this stuff. I run this kind of wire. I don't work with grounded cable. But even the $5 tester can check to at least see if the ground is connected. And the nice thing about this is that I kind of showed you here is that this comes off. The nice thing about the really cheap tester that the more expensive tester doesn't do is on the end that you plug into the other side of the cable, there's no lights on this. So if you need to check and you're doing this by yourself in, say, a big building, or you're working in your house by yourself, you plug the remote end into one end of the wire. You run to the other side of your house, and then you turn the tester on, and then you get your answer, and now what do you got to do? Well, if you got more than one cable, you now have to promptly run to the other side of the house, finish that side, and come back over and then plug this connector in. Well, with this one, it gives you the results on both ends. So if you've got, say, 3 cables in one space, you can make yourself a little bit more efficient with a cheaper tester by plugging in one end, wandering off to the other side, checking that end, and then switch yourself to the next jack, move one of these over, go back to where you started, and then plug this end into the other end. So you're not running back and forth to keep switching both ends and having to read just one side. You can read on either end, which saves you a fair amount of steps, especially if you have a lot of wires, one tester, and no one else to help you. If you're planning on working on a big project, having a friend comes in handy with something like this. Because with a cell phone or a walkie-talkie, or maybe just yelling down the hall, you can tell them to move their end over to the next cable. And boy, does that save on walking. And lots of it. Especially if you've got a closet full of cable. My word. Saves a fair amount of walking. So to answer your question of whether you can use a laptop to test an Ethernet cable. To test an Ethernet cable with a laptop by itself, the answer is no. It's something, well, it's no on a very surface level. And the reason I'm going to say that is that if you weren't sure if a cable worked or not, that was say you're on someone's campus, right? You're at a college campus, and there's a network jack that you have by, say, a public table, right? If you plug your laptop into it and you get internet, well then that's more than likely a functioning cable. But if you don't get a network, that jack could either be turned off by the campus, or it may not be wired, or it might not even be connected. It might just simply be a jack in the wall with no wires connected to it. There is no like test you can really run that I'm aware of. I've only ever used the standalone testers, and there's quite a few people who make them. But brand, I don't really myself care about brand, as long as you can plug it in, turn it on, and it tells you whether the cable passes or not, is really what matters. On the side of my ProGym model here is actually the wiring schema we used this evening. The B setup: orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Now, there are other setups that are less common because the internet has gotten as popular as it is. But on occasion they are still used, or the other wiring schemas. The A setup switches the location of the orange and the green. So you do the same order, but you just flip where orange and green lives. And what that gives you is what's called a crossover cable. Crossover cable is what you would use to connect together two like devices. So 2 switches, 2 computers, 2 routers, 2 like devices. A normal straight through cable like the one I showed you, which is the same thing you would buy off the shelf at, say, a big box store, right? Is going to be straight through on the same time, on both sides, excuse me. It's going to be the same wires in the same order on both ends of the cable. That's called straight through. And it's going to be the B setup. Everybody sells the B setup. But as you probably already kind of figured out, well, a laptop and a switch aren't like devices, so why does that work? Well, being that they're 2 unlike devices, straight through works. When they're 2 like devices, like 2 switches and 2 routers, if there's a specific function by the name of AutoMDIX is not available, it won't work with a normal cable. AutoMDIX is a super fancy term that basically says that both pieces of equipment can figure out how the cable's wired and then figure out how to send their data without any change to the physical wire. So you can use a straight through cable to connect together 2 switches. And any modern switch you could buy off the shelf to have more ports to your network is going to have that. Even the really small ones, like that little 5-port Jobby that I showed there, does that. And that's actually just another thing that's made networking stuff a little easier to use, because it takes away some of that complexity. Because there's enough of it. There's too much of it. As gotta love the madness. It's truly something else. But yeah, when it comes down to it, that's how a little home network works. Your coax comes in, you plug it into your router, and then you get your Wi-Fi from your router, or you plug in an access point. There's lots of stuff you could buy off the shelf that, like I said, does work out of the box. There's other things you could buy that have a little bit more control on them. But that's pretty much the major takeaway of it. In my example, I showed just cable internet or coax. There are other kinds, like satellite internet. There's DSL internet. There's still dial-up internet, interestingly enough. That's the really old one that made all the loud noises, and you would go super slow. Reasonably so. Dial-up, even though it's still purchasable today, you would never want to try to use it to browse the internet. You're not going anywhere fast, or probably really anywhere at all, because of how unbelievably slow it is. So yeah, gotta love that. So, with amongst my madness here, I would like to ask if we have any additional questions. Want to say anything I may have asked, or I may have presented, or amongst the topic? Can people use what free now? So, the answer is kind of yes. If you're going to end up using dial-up for just email, having a program or an email client on your computer would alleviate a lot of the extra traffic. Because right now, like if you say you had a Google email address, then you would have to go to Gmail and then log in and then wait for the page to load and have all that stuff happen in the background. Having a software program like Firebird. Firebird is a program that is provided by the Mozilla Foundation, the people who make the browser Firefox. It's free, it's open source, but more importantly, you can put in your server settings for where your email lives, and then it can connect to it without having to load a bunch of additional pages and screens. The big thing with dial-up is that it's such an unbelievably slow connection that the less stuff you need to ask for, the better. Because the internet truly isn't usable anymore, for the most part, over dial-up. So yes, Firefox makes it. It is called Thunderbird. Thunderbird, spelled like that, by the Mozilla Foundation. And they, yeah, it is cool. So that kind of helps alleviate some of that. Let me see what time we got here. We got, we're kind of getting to the end of this here this evening. I am open to additional requests for things that you may want to see in the classroom setting here. I'm always looking for new topics to talk about. So on my my Twitter, which I am going to go grab my link and put it in chat there for you. I have a post that's at the top of my page, pinned. If there's anything you would like to see as a classroom topic, you can leave me a comment there. And if it's something that I think that I could actually showcase, then I will. In the past, I've done a lot about Microsoft Excel and talked a fair amount at length about a lot of the different functions that live on there. You're welcome. My goal for doing additional classes is
I kind of still want to keep doing them on Wednesday, but even though in my bio here on Twitch says that I'm here at 6:30, my schedule doesn't really line up as good for that as I was kind of hoping it was going to. So keep an eye on my Twitter if it's something that you want to see additional stuff from me, and I will indicate on there what the topic is going to be for that class and when I'm going live. So with that, I want to thank you for coming, and I am going to send us off to another lovely individual. Let me see who is on here that we can shuffle us over to. Give me a brief moment here. I'm in the wrong view.
You really must, darling.
Let's see here. Okay. Alright, I'm going to send this over to another VTuber. This is Flyby Fox. He's a very, very nice individual on the internet. He's currently playing Beat Saber. So, I'm going to take us over there, and I'm going to wish you all an excellent evening, and see you next time. Bye-bye!